Stoichiometry notes, example 9, second year chemistry. Okay, so we have magnesium chlorate reacts with sodium nitride. Please pause this video, write a balanced chemical equation for it. Welcome back. Hopefully this is what you got. If not, please correct yours. Question says, how much sodium nitride must be reacted if the experimental amount of sodium chlorate was 1.26 grams? The yield is found to be 89.14%. I could also add the word percent here. Same thing, or percentage yield. Either way, yield, percentage yield, and these problems mean the same thing. So I have read the word percentage yield. So then I need to think through myself what I need to write. When I read the word percent yield, I need to write A over T equals a percent written as a decimal. So I see the word yield. I'm going to do A over T equals a percent. All right, let me get my marker to be less thick because I already write horribly. Okay, so in this case, we're going to say A over T equals our percent. Our percent must be written as a decimal, 0.8914%. So A over T. Okay, so what are we given in the problem? We're either given an A or we can get given something to get to T. So we have to have the starting amount to get to T. Let's see what we have. It says we have the experimental amount. That's the same thing as A. So we have 126.4 grams of this. Then we can calculate T. Now, how do I know this 126.4 grams isn't T? Because it says experimental. And remember that theoretical has to be from the limiting reactant. It has to be perfect. It can't be an experimental value. Okay, so now we can put this over 1 and cross multiply. Let me bring my screen down and show you what I mean by that. So we're going to cross multiply to solve for T. So that's going to give us 0.8914 times T equals 126.4. Cross multiply. So I'm going to take 126.4. So I'm going to take, on my calculator, 126.4, divide by 0.8914, and I get 141.8 with 4 sig figs. T equals 141.8. If you're unsure of sig figs, you can probably always do 3 to 4. 4 would be your best bet. That's usually what I do things in, is 4 sig figs. Okay, so we got 141.8. That's my T. So now I know that is what comes from my limiting reactant. Let's begin the problem now, because this is what? Remember, A over T, all of this, right, was about sodium chloride. So chlorate, sorry. So all of this was about this. Because remember, when you do A over T, it has to be the same thing over the same thing. Okay, so percent yield has to be apples over apples. A over T has to be same chemical over same chemical. So all of this is about sodium chlorate. So we're going to continue on with this problem and figure out not sodium chlorate, but sodium nitride. Okay, recall that every problem must come from a limiting reactant. So the thing that's our limiting reactant or comes from the limiting reactant is 148.1. So we're going to start with 141.8. I think I said the wrong number ago. I read it wrong. This is 141.8 grams of sodium chloride. And we're going to do a stoichiometric grid, and we're going to get to sodium nitride. So we're going to have to get rid of grams of sodium chloride here. Excuse me, I keep saying chloride. Sodium chlorate here. That's always equal to 1 mole of sodium chlorate. We can mole shuffle next. So we have moles of sodium chlorate here to cancel. Where we're going goes on top. We're going to sodium nitrite. So we're going to have moles of sodium nitrite on top. Pardon me. The number that's with sodium chlorate is 6. The number that's with sodium nitride is 2. So now we're into moles, but generally speaking in chemistry, we want to get to grams or volume. So we're going to say 1 mole of sodium nitride equals how many grams of sodium nitride? We've got to calculate the grams of sodium nitride here. I'm going to do this just to divide the space. Sorry about the writing there. So I'm going to do 3 sodiums, 22.99, times 3, plus a nitrogen, 1401. I get 8298. So this is going to be 8298 grams. So now we have the mass of what we need. We're going to multiply and figure out our value. Multiply and divide. Okay, so we're going to take 141.8 times 2 times 82.98, hit equals, divide by, I got to put in my molar mass of sodium chloride. I did not do that. Let's figure out what that's. So the mass of sodium chloride would be 22.99 for 1 sodium, plus 35.45 for 1 chlorine, plus 3 oxygen, so 3 times 16, and I get 106.44. So this would be 106.44. So we're going to take then 141.8 times 2 times 82.98 equals, divide by 106.44, divide by 6, and we get a final answer here to be 36.85 grams of sodium nitride. Okay, so let's talk about what we did. We started with 141.8 grams of sodium chlorate because that's how much we knew we had from the limiting reactant. We couldn't start with 126.4 because it's not coming from the limiting reactant, because we know it's experimental because it tells us so. Had to do A over T to figure out our T. This comes from the limiting reactant. I can use it as a starting point. 141.8 grams of sodium chlorate. I know there's 106.44 grams of sodium chlorate for every 1 mole. Then I have to do my mole shuffle. And then I know for every 1 mole of sodium nitride, there's 82.98 grams of sodium nitride. Multiply numbers across the top, hit equals, divide by 106.44, hit equals, divide by 6. That's how I get 36.84 grams of sodium nitride.